So we have an object moving at a constant velocity on this horizontal surface. Because it's moving at a constant velocity, the net force on it are balanced. So we have the weight, which is the force of gravity, is equal to mg, and the normal force, because without the normal force, this object will accelerate through the surface. And the force of friction here is equal to the applied force in order for the object to move at a constant velocity. So you should remember in the textbook, the definition of force of friction by definition in the textbook is mu times n. And mu is a constant that depends on the type of surface and whether an object is moving or not. There's static and kinetic. But right now, just make things simple. I'm going to just call that mu, and again, it's just a number that's often given in problems. And the normal force for this case is equal to the magnitude of the weight, so I'm putting mu mg. Not very complicated. Let's move on to the second part here, the incline. So if you have a box resting on an incline, we in order to figure out the friction force, we need to draw a free body diagram. And in earlier video, you practiced drawing free body diagrams for many problems. So hopefully you're able to do that now. And so the normal force here is perpendicular to the surface, is pointing 90 degrees to the surface here, and we have a friction force is up the incline, is represented by this right here, force of frictions, and we have the weight, which is mg again. So to make things simple for me, I'm just gonna call this the y-axis, and I'm gonna call this the x-axis right here. The reason I do that, then I only need to worry about this vectors and its components. So this vectors has a x component, which is this way, and a y component. And when you add these two blue components together, you should get the y component, which is the force of gravity right here. And a vector can be broken into components. That's also another video that I have created if you don't understand what I'm saying. So this right part is mg cos theta. This is mg cos theta. And that blue line right here is mg sine theta. This is vectors, mg sine theta. And what theta am I referring to? I'm referring to this angle right here is given to you. Okay, you can take note and write this two formula down. So when you solve problems, you can just use it. But some of you probably wondering, okay, how did I come up with this? I don't just want to remember it, I want to be able to come up with it. Well, it just requires a little bit of trigonometry here. First, draw a parallel line, and then you need to find that angle first, and then you just know that angle is 90 minus theta, because a triangle has 180 degrees, and right here is already 90 degrees, and that's theta, so therefore this would be 90 minus theta. Okay, not big a deal. You can put a number and you see that, and you add them all together, it should be 180 degrees. So the next thing you need to do is you need to find this angle. When you find this angle, then everything should be good. So what is this angle, right? This angle is nothing more than 90, because this is a 90 degree right here. This blue line and this blue line make a 90 degree. So 90 minus this angle, which is 90 minus theta. So in conclusion, what you have is theta right here. Okay, so once you have theta, you only need to use the definition of sine and cosine, and I expect you to know that definition. If not, watch another video on the definition of sine and cosine. So if this is theta, right, and this is the hypotenuse, the y line is the hypotenuse, and is represented by mg, so therefore this component is mg cos theta, and so this component is mg sine theta. Because this is the same as this blue line, you make this blue arrows mg sine theta. Okay. Hopefully that makes sense. If it doesn't make sense, make sure you review the definition of sine and cosine, and it will make sense. Okay. So back to what is the friction force for this box right here. So the definition for friction force is mu n again, and n in this case is what? N is the magnitude of n is equal to mg cos theta, so therefore mu mg cos theta is the friction force on this box. Okay, that's it for this video. I will see you in the next one. See ya.